This is GCSE Further Mech Applied, and we're starting to look now at some mechanics. This is chapter 1, Displacement Velocity and Acceleration. So just a wee bit then on displacement velocity. Displacement is a bit like distance, but it tells you how far you are away from a certain starting position. So it's effectively distance with direction. Travelling the same distance but in opposite directions will be shown by one being positive and the other being negative. Consider travelling from Carrick to Belfast and then back. The distance is about 25 miles, but the displacement will be 0. If you travel all the way to Belfast and back again, your displacement is 0. That's how far you are away from your starting position because you're back in Carrick. However, the distance travelled then is 25. Velocity, similar. It's speed with direction. Again, we use positive speed in one direction and negative in the other direction. Okay, so displacement, velocity and acceleration are all vector quantities. A vector has size and direction. That's what we just said then, so we're talking about having a direction. Displacement time graph. Displacement is distance with direction, travel the same. That's exactly just what we've said. The gradient of a displacement time graph tells you the velocity in that direction. So if we work out the gradient there, obviously the rise over the run, then that'll work out our average velocity, because if you take a wee look at it, I guess it tells you how your displacement changes where you are in terms of time. So at 0 seconds we are 5 meters away, and at 3 seconds that looks like we are sort of 25 meters away. So that's the way this one then works out for us. So this is because average velocity is displacement over total time taken, and we work out the gradient using rise over run. From the graph above, the gradient of the first section is given by 20, so it's gone from, let's just draw this wee bit in. So as I say, it's gone from 5 up to 25, so that'll be 20, and then over 3 seconds. So that then would be 6 2/3 meters per second. In the second section, the horizontal line indicates a velocity of 0, as in between 3 seconds and 6 seconds the displacement doesn't change, so it mustn't be moving. In other words, if the gradient is 0, then the object is not moving, it is stationary. The gradient in the third section is given by minus 25 over 2, so let's take a wee look there. Sorry for the moving up and down here. It would be that bit there. That would be the minus 25, because going down 25 and 2, minus 25 over 2, so a velocity then of minus 12.5 meters per second. The negative sign for velocity means that the body is travelling in the opposite direction. So again, we'll go back up here. This is not the smoothest of operations, forgive me, but this is it kind of going away, if you want to think about it. It's 5 meters away, it's 10 meters away, it's 15 meters away, it's now 25 meters away, and then this is it coming back between 6 and 8 seconds all the way back in the 0 where we start. If there are two graphs on the same set of axes, the point of intersection is the point where both objects have the same displacement, i.e. when the two objects are in the same place.